potential energy. Energy possessed by the body by virtue of its position. Body raised to a height. Water stored in a tank. Example for potential energy. It is raised, any body which is raised to a height. We call it as potential energy. So potential energy near the surface of the earth. Suppose you have a body, this is ground level. Here we have a body of mass m. Gravitational force. This is F.e.a. Downwards gravitational force. You are moving the body by giving some energy in the upward direction. Same, work done is equal to potential energy. Along the direction of force body is moving, so theta is equal to 0. So I can write integral F.e.a. dr. That is integral F.e.a. dr cos theta. So potential energy is equal to integral F.e.a. dr. Cos 0 is 1. You are moving the body from the ground level up to a height h. So 0 to h is the limit of integration. Minimum value, maximum value, 0 to h. F.a. Take it out. Integral dr is nothing but r. Limit 0 to h. F.a. equivalent value, that a downward force, that is nothing but mg. Body placed at a height, the force acting downwards is nothing but weight of the body, mg. Upper limit minus lower limit, h minus 0. So that we call it as mg. So work done is equal to potential energy, that is nothing but mgh near the surface of the earth. When we go extraordinary high altitude, this value will change because g is not constant. G is variable in that case. Okay, next elastic potential energy. You consider an example of a spring. You are elongating the spring and you are compressing the spring. Elongation, compression. Elongation, this is called elongation. This is called a compression. This is the original position. You are applying a force to elongate. F.e.a. This is Fs. Spring force. This is the accelerating force, that is the applied force. And this is Fs called the spring force. In the opposite. Always applied force and the spring force will be opposite. Here, this is applied force. This is spring force. Correct, Amma? Fine. So what is the work done formula? Work done is integral FA into dx. No, sir. dr only I put. Okay, you put dr. You can very well write this is R. This is elongated by a displacement, compressed by a displacement. Okay. Along the direction of force only the body is elongated, or along the direction of force only the body is compressed. So theta is equal to 0. So I can write FA into dr. But F is equal to FA is kx, Fs is minus kx. K is called spring constant, force constant or spring constant. So formula W is equal to kx. No, sir. R only. Okay, kr. If you want to put displacement as dx, here also you can put dx. Displacement dr, here also you can put dr. No worry. Dx only I am representing, sir. Can you write dx? Okay, so kx dx. So W is equal to, what is the formula? K you take it outside, x square by 2. Half k x square. Sir, I have 0 to x. Limit means you can put limit 0 to x. No, sir. Limit is x1 to x2. For a certain point, I want to calculate x1 to x2. So you can write half k constant x square x1 to x2. So half k x2 square minus x1. X2 square minus initial x1, final x2. This is called elastic potential energy in the case of a spring mass system. Okay, fine. Next term. Sir, can we represent this by a graph? Yes, you can represent by a graph. Fs is equal to minus kx. Displacement is x. So, draw a graph. F is equal to minus kx and the displacement along x-axis. In the case of displacement along x-axis, you can write one negative, one positive value, minus value and plus value. Minus value and plus value means what, sir? It should be in second quadrant or it should be in fourth quadrant. Here, a second quadrant only one minus value and plus value you are getting. Fourth quadrant, one negative, one positive. So, the nature of the graph is a straight line. Displacement. Like this. Join. As usual, what you have to do? You have to calculate the area. Area of the graph will give you the work done. Area of the graph will give you the work done. So what is the concept? This is nothing but a triangle. So work done W is equal to half into base into height. Half into magnitude alone. We are taking magnitude half into base x height kx half kx. This is not straight line portion, sir. Suppose the body is moving in circular path. What is the work done? Body is moving in circular path means the force applied towards the center, we call it as centripetal force. This is the displacement of the body. Theta 90, work done 0. We have discussed cases no ma for work done to be 0. In this circular motion also work done is 0. Centripetal force and displacement. So in this case, work done is half kx square. Graphically also you can calculate. Sir, potential energy, kinetic energy I have. Then how to represent in a graph? You can take the example of simple pendulum. You take a pendulum, oscillate it. When it is getting oscillated, extreme position, the velocity becomes 0, so it moves, accelerates in the opposite direction. So extreme position, velocity 0. Mean position, there is no displacement. So potential energy is 0. Extreme position, velocity 0 means kinetic energy is 0. So both extreme position, kinetic energy is 0. Mean position or equilibrium position, potential energy is 0. So when you draw a graph, displacement, this is extreme position. This is total energy. How will you represent? Extreme position, velocity, that is kinetic energy is 0. Kinetic energy is 0. Mean position, potential energy is 0. Kinetic energy is maximum. So join these 3 points. This we call it as kinetic energy. Mean position, potential energy is 0. Extreme position, potential energy is maximum. Join these 3 points. See potential. Correct, Amma? Simple. Graphical representation. Law of conservation of energy. Energy is conserved. Total energy is conserved. Conserved means constant. Energy can only be transformed. It cannot be created nor be destroyed. Energy cannot be created nor be destroyed, but only can be transformed from one form to the other. Simple example we can take. This is the ground level. At 3 different points, here, here, and here. You have a box. The body is raised to a height, say h. At the highest point, you know very well, kinetic energy is 0, potential energy is U. So total energy is equal to U because kinetic energy is 0. Maximum point, you are throwing an object, the velocity goes on decreasing, highest point velocity becomes 0, so only the body is coming down. The velocity goes on decreasing. So potential energy means velocity is, in this case, velocity is going on decreasing. Suppose the body is moving with constant velocity. initial and final point. That alone we are going to calculate. Okay. Lowermost point. The moment the body touches, the moment it touches, not after it comes to rest. Moment it touches the body, touches the ground level, what happens? Kinetic energy is maximum. Potential energy is 0. So total energy is entirely kinetic. Here the displacement is y. Here it is h minus y. So kinetic energy plus potential energy together only we call it as total energy at the midpoint. Energy is fully potential. Energy is fully kinetic. Energy is kinetic and potential. It is not half kinetic or it depends upon the height. This is law of conservation of energy. Right? Next we'll go for power. Rate of doing work we call it as power. That is, power is nothing but work done by time taken, dW by dt. Small change in work done in small interval of time, dW by dt, we call it as power. So power is equal to work done by time. W by T or dW by dt. Unit of P, joules per second or watt. Watt, W-A-T-T, scientist name. What is the unit of power? 1 kilowatt, 1 megawatt, 1 gigawatt. Kilowatt means 1000 watts. Mega means 10 power 6 watts. Gigawatt means 10 power 9 watts. Even now also we are using for motor pumping and all. Horsepower. 1 horsepower is equal to 746 watts. Half HP motor, 1 HP motor, 2 HP motor and all you heard. 746 watts, 1 horsepower. Sir, I need power in terms of velocity. You have written work done by time. Work done is dependent on force and displacement. So I can write power is nothing but W by T. That is F vector dot S vector by T. F vector dot S by T is what, ma? Velocity, displacement by time. So I can write this as Fe cos theta, power. So it is a scalar product of two vectors, force and velocity. Scalar product of two vectors, force and displacement is work done by time. So force and velocity is called power. Okay. Sometimes energy for household concept and all, how to calculate energy, that is called 1 kilowatt hour. Watt is a unit of power, hour is a unit of time. Watt, power into time is nothing but work done, that is nothing but energy. This is called 1 electrical unit, 1 kilowatt hour. What is the meaning? 1 kilowatt hour means 1 kilo, 1000, 1 kilowatts, 1000 watts. 1 hour means 3600 seconds. So 36 into 10 power 5 watt into second. Watt into second is nothing but joules. This is called 1 unit, what is being consumed. This is what you are calculating in your house. 100 unit, 200 unit, 550 unit, 375 units, and you are telling no. 1 unit means this much amount of energy is spent. 36 into 10 power 5 joules of energy is spent. That is called 1 electrical unit. You can calculate. This much amount of any bulb, tube light is given, or 60 watts bulb, 40 watts bulb, energizer 9 watts, 12 watts, 25 watts. If it is burning for this much time, what is the power consumed? We have discussed in the first part. Convert everything into 1 kilowatt hour. That 1000 watt hour means 1 unit. 40 watts tube light, 25 hours it is burning means I am getting 1000 watt hour. So 1 unit. That's all. Like that, for any appliance you can calculate. Provided how many hours it is burned and what is the power of that particular unit. Multiply 1000 watt hour means 1 unit. Depending upon your consumption, unit will change. Correct, Amma? Fine. Next, collisions. 2 types of collisions. Only collision means one body is colliding with other body. Physical collision. This is elastic collision, inelastic collision. 2 types. Elastic means collision between microscopic particles, subatomic particles, proton, between 2 protons, between electrons, between proton and neutron, subatomic particles. After collision, kinetic energy is not lost. Then you call it as elastic collision. After collision, kinetic energy is lost. We call it as elastic collision. Whatever collision we come across in our day-to-day life is nothing but inelastic collision. Subatomic particle collision and all you can read, but practically you cannot see that. Okay, ma? So elastic collision, inelastic collision. Collisions. Momentum and kinetic energy both are conserved. Total momentum before collision is equal to total momentum after collision. Total kinetic energy before collision, total kinetic energy after collision. You can write for elastic. But inelastic collision, total kinetic energy before collision is not equal to total kinetic energy after collision. So, kinetic energy before collision, kinetic energy after collision. This is not equal. In fact, after collision, kinetic energy decreases. So, this is nothing but loss of energy, delta E, loss in kinetic energy. So, that is your second part of work power energy chapter. First, we have discussed about work done. Then, we have discussed about energy, types of energy, kinetic energy and potential energy. Then, what is called power. Thank you. We continue.